Today, I feel like we hit the big leagues with the MLOps community. We have finally gotten on my man Alexey, who this has been a long time coming, man. We said we were
Yes.
going to do this in, when was it? May, I think we
Well,
originally
first we wanted to do it in April, but then in May, and now.
and then June, and then it got all pushed around. So this is cool that we're finally able to do it. I feel like persistence pays off, and we did it. If any of you are new here and you've never come, this is your first time, I'm Demetrius. I am part of this whole MLOps thing. We have a few people behind the scenes that help us. My man Chris is here, and he will share a link to our Slack community where we are fortunate enough to have Alexey in it. And the idea of the Slack community is anyone who wants to know about MLOps or has anything to say about MLOps, if you're writing anything on Medium or you have a blog or you have videos or you're just curious about whatever, feel free to join the MLOps community and get involved. So it is now in the chat. You should have a link if you want to join us. We are making it a hub so that if you have questions about MLOps, anything, we've got a lot of smart people in there, a lot of people that are very much smarter than me, and they can answer these deep technical questions that they have experience with. So feel free to jump in there. Your voice is always appreciated. And without further ado, we will begin the 25th meetup, MLOps meetup. I'm going to stop sharing this screen so that y'all can see me and Alexey. So Alexey, I'm happy to have you here. It is, like I mentioned before, it's been a long time coming so that everyone can know who you are. You are a lead data scientist at OLX, and you're based out of Berlin. But the way that you caught my eye, and I think a lot of people probably know you because they follow you on LinkedIn, you are of LinkedIn influencer status, I think. If it's okay to say that. That's why I think we hit the big leagues today when we got you on here. And what you've been doing, which has been really, I guess, fascinating for me, is you've been helping people in their journeys to become data scientists. And you created a GitHub repo that it blew up. Let's be honest. It's an amazing, valuable piece of information. And if you have a link to that, I forgot to bring it, but we can put a link to that in the chat, because what it is it's questions and answers for interview, like being a data scientist and interview questions for data scientists. So that was immensely helpful. I think many people found that to be incredible. And because of that, you skyrocketed to stardom. And then it turns out you got a lot more than just questions and answers to say, and you have valuable information to give us around full stack data scientists and what that means. Today we're going to be talking about, is that such a thing? Is it feasible to think about trying to be that and trying to do that? If I am a data scientist, what else do I need to know besides just the statistics? And so before we get into all of that, I'd love to just get a quick rundown of how you got into data science, and then also, like, you're not from Berlin, but you're based in Berlin now, right?
Mm-hmm.
And so how you wound up in Berlin, all of that good info, if you want to just give us a quick one.
Mm-hmm. Yeah. Most of the people I know who are in Berlin now, they are not from Berlin. This is like one of the places where people come to. They are not born there. So I'm originally from Russia. So I first became interested in programming. I think I was like 10 years old. I found a book about programming in the attic of my grandfather. So it was a book about basic, and like it had like all these block diagrams. It was fun. I didn't have a computer back then. But I had a friend, and sometimes I went to my friend, and we would create a game in HTML. So it was fun. Eventually I got a computer myself. And then I had Delphi on it. I didn't have internet, so it was fun to figure out how to solve some things without internet access. Actually, when at school I was thinking of doing chemistry, but there was no chemistry department in my city. So even though I was kind of interested in programming, I thought I would do some chemical stuff. But there was a computer science department in my city, in my university, and this is how I got into tech. And then after 5 years after graduation, I started working as a Java developer. So this is when my professional tech life started.
And then what brought you to Berlin?
Yeah, so to Berlin, actually, so that I was still in Russia. And then I first moved to Poland. So there in Poland, I worked also as a Java developer. It was quite fun working, but then I worked at a bank. The job was great. It was high load, a lot of data, but I somehow wanted to do something different. And then around that time, there was a course on Coursera. Maybe many people know this machine learning course. I watched that course, and then I decided, okay, this is what I want to do. And I tried to switch my career. It wasn't really easy back then. So back then, people didn't know what they wanted to data scientists to do. So I decided to get extra education, to get a master's. So I enrolled into a full-time master program. And that program, it was like a degree between multiple universities. The first, I spent first semester in Belgium, then in France, and then eventually my specialization was in Berlin. And this is how I ended in Berlin. So it I decided to do specialization in, it was large scale data intelligence. And this is how I ended here. So I didn't know much about the city back then when I decided to go there. But when I graduated from master's, I realized that this is a really great place to be for a data scientist.
Yeah, great place to be in general, I think. It's an awesome city. And everyone that's been to Berlin knows that one. So can you tell us what a full stack data scientist means to you? Because you obviously are coming from this Java background. You got into data science, and then I imagine you kept learning. And what is it that when someone says full stack data scientist, what do you visualize?
So first of all, yeah, I kind of agree that coming from this development background to data science gave me maybe an extra angle. So I kind of knew how to do software development, and then I learned how to do machine learning. And many people have called me a full stack data scientist because I kind of can reach two worlds. So what I personally see as a full stack data scientist, so this is somebody who can do the whole cycle, who can own the ML project end to end, like from the very beginning, from the inception, when you just collect the requirements, talk to people, try to formulate the problem in terms of machine learning, and even think like, okay, do we even need machine learning here to solve our problem? Then if we decide that we do need machine learning, then there is a bunch of other things like the preparation, then the actual machine learning, like when we train a model. Then we need to evaluate the model on real users, then deploy, of course. So having this end-to-end ownership is, I think, this is what full stack data scientist is about. So not just one specific part of the process, like when you focus on modeling, like something you do at Kaggle, but actually doing pretty much everything else in addition to that.
Yeah, that makes sense. Now, do you feel like that is something feasible for most of us, or is that just like one in a million kind of thing, that if you've been programming since you were 10 without a computer, then you can do it.
Yeah. Well, yeah, it kind of feels like this full stack data scientist is like a superhero, right? Like somebody who can come and like do the project all alone. But superheroes don't exist, right? So it's not real. And then if you think about like like the whole process of a machine learning problem, a project, then there are many different steps, right? And then actually for each of these steps, you need a separate person, like even multiple people who focus just on this step, right? So it's kind of not realistic to expect like from just one single person, even somebody who's been programming since they were 10, to actually be able to do all that. But I think it is realistic, because the key thing here is we don't need to be experts in everything. So just to know a little bit of each step, like what is involved at each step, and what are the core things to do at each step. Like, for example, for requirement gathering the requirements is like talking to people, trying to understand what they mean, trying to prioritize things. Or, for example, for data preparation step, maybe just knowing where the data is and how to effectively extract this data. So you don't need to be a professional data engineer to do this. Maybe just a course on Udemy or just some YouTube videos are enough to get the basics. And the same with machine learning, like this MLOps thing, right? So when we go to the final step and we have a model, we want to deploy it. We also don't need to be expert DevOps engineers to do this, right? So because there's probably a system and there are people who maintain this, and we just need to be good users. We just need to know like, okay, let's say we have Kubernetes. How do we deploy it? We don't need to be experts in Kubernetes to do this, right? We don't need to know how to manage a Kubernetes cluster. All we need to know is how to create a simple service in Kubernetes that can scale up and down. And then if something doesn't work, we shouldn't be afraid to ask for help. And I think this is who a full stack data scientist is, who knows a bit of everything, not afraid to do this alone, but ask for help when it's needed. And the main thing is you shouldn't wait for somebody to come and help you, right? You shouldn't be stuck. You should try to do these things yourself. But when you're really stuck, then you go and ask for help.
It brings up such a good point when you talk about needing to know, or not needing to know, but just learning about each piece of the puzzle. And I know that when I was doing a little research on you and reading all your past LinkedIn posts, that you get a little heat on LinkedIn sometimes for saying that. People are very opinionated. It's like almost like they don't like to hear that, oh, you just learn a little bit about Kubernetes and then you're good. And if something breaks, then you go and ask someone for help. Because in their eyes, it's like, I took, months to learn Kubernetes and I still am not delivering any value for my company and I'm still lost. And so can you speak to that a little bit? Like, how is it that, like, if I'm going to be providing the most value doing data science stuff, because that's where I'm an expert in, is it realistic for me to then go out and learn Kubernetes? Or is that something that maybe it's not worth my time?
I think it's totally realistic. And the reason I was doing this at some point, like learning all these tools, is because I was blocked. I needed somebody to help me do something, right? And then these other people, like data engineers, software engineers, DevOps engineers, they are always busy with other things, right? Because they all have their own priorities. And then all of a sudden, somebody like a data scientist comes and says, "Hey, can you please help me with this?" And then just wait till I finish something, and then let's stop. And then you can wait 1 month, 2 months, like forever. In one instance, and I needed to wait like for half a year. That was too long. But usually you can just ask, okay, if you're busy, teach me how to do this and I'll do this myself. And this is easier to do usually, and then usually they are quite happy to provide you with the resources. When I was in this situation, I asked our site reliability engineer I asked him for advice. How do I learn Kubernetes? And his suggestion was install Minikube, go through the tutorial, like Hello World tutorial, and learn all the bits of Kubernetes, like how to create a pod, how to create a service, how to create like deployment, all these things. And that was enough. So, and then we did it once together. So I showed that I'm somebody who can be trusted. And then I could do this alone later. And it helped me not to be blocked. I didn't need to wait, so I was more independent. And I could iterate faster. So this brings a lot of value. And also, I don't need to spend time of other people to help me do my job. So I think this is what makes it more valuable, like that you can move fast and be independent.
Yeah, you're not taking up resources from other parts of the company. I'm wondering though, is it not dangerous if you're just putting whatever into production through Kubernetes and you have just a little bit of experience, and because if I understand this correctly, you're saying just you're proving out the business case of this, or is this like really production level? You're ready to start scaling this. What are you talking about here?
Yeah, so like there are multiple levels, and probably a good SRE, a good DevOps will not let a data scientist touch production, right? And unless they really trust them. So in many projects, I didn't have access to production, but I did have access to staging. And that was enough to actually to show that, okay, to have some sort of skeleton, which was possible, like if you use Kubernetes, like you keep everything like as configuration. And then if it works in staging, then it's easy to actually move it to production, relatively easy, right? So it's good to have this sort of playground, like a safe place where you can experiment with things, like a staging environment or a separate cluster just for experiments. You play there, you try different things, you're not afraid of breaking anything. And once it's something stable, maybe test it a bit, then you can move it to production, and then of course ask for help. If people are busy, this can also happen. Well, that's probably you need to somehow convince them to do this, but it's a lot easier to convince them when it's already working in staging. Then it's a lot less work for them to actually to move these things. Maybe a couple of hours, like if it's not too complicated. Usually it's not, like it's just a couple of deployments and then maybe a couple of services.
Yeah, that makes sense. And it's a much safer way to go about it. You're not going to bring down the house with some rogue model that you put out on your Minikube cluster or whatever. So now, can you talk to us, for people that want to get more into infrastructure topics, how would you recommend going about that?
Well, like I said, just go to people who usually do this at your company and ask for help. Like say, hey, I want to learn a bit of what you do to be more independent, not to bug you always, like all the time. And they're usually pretty happy about you not bugging them. So they will they will teach you, like show a couple of tutorials, like show the tools, and this example with Minikube. So this was specifically the case when I asked, like, hey, can you show me like the ropes, like how to be more independent? And this is how I learned about Minikube, that I can safely experiment on my laptop or maybe on EC2 machine on Amazon. Just put it there, try to see how config files look like in Kubernetes, and just learn the tool before even going to staging environment. So the best advice from me would be ask for help, like ask for tools, maybe do some pair programming, and then you also need to earn trust, right? So for a data scientist, it's probably difficult because usually when engineers look at our code, they are not always happy. So somehow you need to show that you can be trusted. So maybe you need to do this a couple of times, deploy with somebody else, like maybe with an SRE. And then once they see that you can be trusted, then try to do this alone. And do this a few times without breaking production, then that's
then they give you the green light.
Yes.
So can you talk to us a bit about, because almost 2 months ago now, we had Alex Spanos on here, and he was talking to us about this third wave of data scientists. And he was mentioning, in his eyes, the data science title is very broad, and he feels like that's going to evolve. And actually, Jet, was it last week or 2 weeks ago, was talking to us about that too, because it's just such an umbrella that so many things fall under. Like yesterday we had Lena on here. She was talking about monitoring and finding bugs in your ML models and how you go about that. You have this part about deploying it. You have parts about just building certain kinds of models. All of that it can be its own world in itself, right? So can you talk to us about if you see that evolving and how?
Your question is basically like how the data science field will look like in the future, or?
Yeah. And like the roles, really, what the roles you feel will look like. Do you feel it's going to change or not?
Yeah, I think like when it comes to roles, I remember when I was a Java developer and was looking for a change to switch to data science career, to do data science, it was pretty different. So the expectations from the person, from a candidate, was that somebody with a PhD in mathematics, somebody who knows Hadoop. Like I don't know how these two are connected, but this was my experience. It changed since then. So when I graduated, when I got my master's, it was 2 years after that. This PhD requirement was already optional in many job postings and listings. So like people realized that PhD is not really needed. It's a nice to have thing, but it's not a must. I think now, like somehow, like the role data scientist diverge to two things, two quite separate things. So what I see in the States, mostly in big tech, is now data scientist is somebody who is not always like, it's not always about machine learning. Sometimes it's more about like BI, something like somebody who is more like in SQL and then trying to get some insights from data, doing traditional analytics tools. Then maybe running some experiments, A/B tests, and things like this. And then there is data scientists that I see mostly in Europe now, like in Germany, for example. In Berlin, it's somebody like who knows some SQL to extract data, who knows some Python and pandas to clean this data, to prepare it in the right form, then knows like scikit-learn and TensorFlow, like machine learning frameworks, to actually get this data and train a model. And then they also know a bit of maybe Flask and Docker to actually package this together. So I kind of see these two streams. And also there is a tendency like this second data scientist, I think in the States, like is mostly referred as ML engineer. So I think this is where it's going, because usually the trends are coming from the States to Europe. So probably in a few years, the data scientist here will be more like an analyst role, and then we'll have ML engineers, but I don't know. What I also see in the field, I think it becomes more commoditized. Like you have all these ML, auto ML tools, like all these clouds where you can just drag and drop things and then have a model out of this. So I think it makes the like the learning curve maybe less steep, and also like people without the math background can easily enter the field and already start doing things. So I think the focus will be more like on the engineering side of things, because like with all this AutoML, you can get a model, but then you'll need to spend a lot of time connecting these different tools together, like connecting cables, and this is mostly engineering work. And I think this is where the field is going. Like you need to, like, probably the trend will be like you need to be able to understand business domain pretty well. And I think this is like I read an article that you mentioned. So I think they're like this third wave data scientist, somebody who understands business pretty well, like product oriented person, somebody who knows why we are doing this. And then somebody who is a good software engineer, like good developer. So I think this is where the field is going, and I think it's nice to have these two qualities to be a successful data scientist. It might not be called data science, but to do this work that we are doing, I think it's nice to have these two things.
Yeah, and it's interesting that you say that the emphasis is going to be more on this software engineering side, because I was wondering if in the future that is going to be needed at all because of the tooling that comes out. And what I've been seeing, like you mentioned, is there's a lot of tooling that helps you get your models into production. There's a lot of tooling that helps you collaborate with Jupyter notebooks or helps with pipelines, all of that. And so I'm wondering, you still feel that the software engineering is going to be a big piece because of how you patched all of that tooling together? Is that what I understand?
Yes, that is one of the things. So yes, because you somehow need to connect all these cables so they work together. Because I remember there was a quote from somebody that 80% of the time is spent on, like in software development, is spent on data integration. I don't think it goes away anytime soon. So we will still need to spend a lot of data, a lot of time on actually connecting all these different tools together. And then the other thing is, okay, let's say we have a cloud and we have this AutoML tool that you just use the visual designer, you connect it like these squares, and then the data is flowing, transforming in the way you want, magically cleaned, and then you have a model. But then this model needs to be used. And typically what many companies have is like a big fat monolith written in PHP that needs to actually somehow consume this model, right? It doesn't have to be PHP, but it can be Java, or I don't know. Or if you're lucky, maybe it's a bunch of microservices, but somehow still needs to be consumed, right? Or maybe you need to save this data somehow to a database. But and I think there will always be some engineering work to actually not just produce the model, but also be able to consume it and to make it valuable. So it's not just sitting there, but it's actually solving problems.
Now, with all of these things that a machine learning engineer or a data scientist has on their plate, like learning about machine learning theory, learning about frameworks or MLOps tools, any kind of platforms, ML platforms, how do you recommend selecting what to learn and because maybe you spend a year playing with one tool and then all of a sudden it's not the cool tool anymore and you have to relearn. Do you have any recommendations for us on that?
Well, it's kind of a tricky thing, because I remember when I was studying machine learning, so it's like a slightly different thing. Like instead of tools, there is a bunch of theory, and it felt to me like that I needed to learn all that to be able to use machine learning. Like I needed to know what are these support vector machines. I needed to know all the math behind them, like all these 2 years of calculus that you need to know to be able to understand how it really works. And then in addition to that, there is a bunch of other models, all require some pieces of math. It's all very complex. You need to really dig deep to understand what's going on there and to be able to work through all the derivations to really understand what's going on. But actually, if you think about this, you don't really need to know all that to solve a real life problem, right? So let's say you want to predict churn. You don't need to know like all these Slack variables or like all these mathematics that you have in support vector machines. You just need to take a library, set up a cross-validation scheme to make sure your model can generalize well, and just train it. Like maybe think of it as a black box initially. So what I'm trying to say is, like if you really focus on the problem, let's say you want to solve churn, you don't need to dig deep. You need to stay at the right level of abstraction, then find the right tool and just solve your problem, right? And if we talk about MLOps and we want to deploy our churn prediction model, then we just have a look at whatever is there in our organization and try to use it to solve our problem instead of spreading, trying to learn everything at once. Just try to focus on solving one particular problem using the tools available. If there are no tools available, maybe try to do research and create a small prototype. Like for example, with this Kubeflow, seems to be a cool thing these days. Doesn't take a lot of time just to install it and just see what it can do, and then maybe forget about this or try to use it and see if it works or not. So yeah, focus on the problem and just don't try to spread your attention to too many things at the same time.
Yeah, I grin a little bit because yeah, Kubeflow in theory doesn't take a lot of time, but
well, if you go through the tutorial, it seems easy, right? If you go outside.
Yeah, anybody that's messed around with Kubeflow a little bit may have other thoughts and feelings about it. But I think there's some questions from LinkedIn, and I also see Tejas is asking one in the chat. So I'll get to that one first. With Spark bringing the best of both worlds, big data and ML in a single platform, what is your opinion about PySpark?
Well, PySpark is a great tool, actually. So I think I have used it, and it's mature enough to be quite stable and solve the problems. Of course, there are some cases where you need to spend a lot of time trying to get most of it. But I'm a fan of Spark. I think it hides all the complexity of all this, like, getting data sets, scaling it to many machines. And then, for example, if you have a model and you want to predict, to apply this model to all the users that you have, with Spark, it's pretty easy. So you just, read it from S3 or whatever data storage you have, and then apply this model, and then you save the results. So it hides all the complexity. Of course, sometimes it breaks, and then you need to spend a lot of hours figuring out what's going on. But I think it's a pretty nice tool to have in your belt.
Another one from LinkedIn. They were asking, can you give me suggestions on what resources, real world projects, books, application level tasks that I could use to step up my data science knowledge?
Yeah, so I don't know if you mentioned, but I'm working on a book right now. So this book is called Machine Learning Bootcamp. And I can tell a few words about the book, but of course my suggestion would be to use this as a resource for learning data science. This book is aimed at software engineers who want to transition into data science. So as a software engineer myself, I went through this process of trying to learn machine learning, and I think I understand what works best to do it. And in my opinion, it's focusing on the project, focusing on the problem, not on the solution. And this is the approach I use in my book. So there is a problem. Let's say we want to predict the price of a car, and this is how you solve this problem step by step. Instead of like we do at university. At university, usually, like there is a bunch of theory. So first you study the theory, And then at the end, maybe they show you a bit of applications, like how you can use this. This is the other way around. So there is a problem, and this is how you can solve it using framework without getting too deep into the theory. So I think for for somebody who is just starting, especially if you already have a coding background, this is a really great starting point. Well, my book costs money, of course. Maybe you don't want to spend money on a book. So I know many people don't like buying books. There's a good alternative. Something that worked really well for me as well is Kaggle. So you go on Kaggle, and basically you don't need to think about a problem yourself. So there are already problems that you can just pick and try to solve. For a software engineer, I think it works really great because you just need to focus on solving this problem that organizers already prepared for you. So you read forums, you try to Google things, and you just find a way to solve this using maybe kernels, forums, like all the available information. And this really helps. And for a software engineer, it shouldn't be too difficult. You just need to know a bit of like jargon, like what things mean, like what is cross-validation, what are all these models like, and how to install scikit-learn, things like this. And I think it's also a good way to start to get into data science.
Let's talk a little bit more about Kaggle real fast, but
Okay.
before we do that, I wanted to mention that I think you're giving away a few of your books, right? And especially to anyone who's in the MLOps community. I threw it in the email. I'll throw it in this week's email too. So anyone that's here, you can enter to win one of his books. And I know it's an ongoing process, so new chapters are continually coming out, right?
Mm-hmm.
And so for those people who don't like to pay for books, you may win one just for showing up today and having Alexey be a really stand-up dude. And so let's get into Kaggle. And I know there's a lot, like there's people that are very much for it. I know it has a lot of value. It brings a lot of value to quite a few people. And I know that there's also people that don't believe it's realistic because the data and everything that they give you is very clean and it's a very well thought out problem. And when you get into the real world, you're not hit with anything that looks like Kaggle.
Mm-hmm.
So can you talk to us about that and how to transition from being a Kaggle master into an actual data scientist that has to go to the 9 to 5?
Yeah, so one thing I definitely agree with is that competing at Kaggle is not the same as working as a data scientist. So these are two completely different things. So Kaggle focuses on one aspect of data science. It's like being good at training models. This is an important aspect, right? Because maybe in Kaggle, the focus is more on being the best at work. You don't need to be best. You just need to be okay, sufficiently good. Yet, I think taking part in Kaggle competitions makes you an expert in machine learning. So it really teaches you how to create features, how to tune your model, how to set up cross-validation to make sure that the model doesn't overfit. And all these things, they're quite important. And like there are a bunch of the tricks that you learn along the way that are also useful in the day-to-day job. And these things that I mentioned, like feature engineering, cross-validation, they're also important. But as I said, in Kaggle, the focus is on being the best. And it sometimes goes a bit too much, like creating all these complex models just for an extra third, fifth decimal point. Of course, in real life, you don't need to be that precise. But still, I think it teaches you a great deal of things that are useful in real life. Of course, the data is already there, like it's sort of cleaned. So somebody already thought about the problem, formulated, collected all this data, did a bit of pre-processing step. But also, I think it's quite useful to take part not just in one competition, but in multiple competitions. Maybe not actively, just to see what's going on. Because even though the organizers indeed went through all these troubles of setting up problems, I think it broadens your horizons of what is possible to do with machine learning. Because you just see like somebody already formulated the problem in terms of machine learning and came up with a way to measure the success, like what kind of metrics we should use to evaluate these models. And if you just come to Kaggle, I don't know, once a month and see what are the ongoing competitions there, what problem they try to solve, what metrics they use, and maybe if competition just finished, what was the approach for the winning teams, then you can learn a lot. And many of these things are pretty useful in day-to-day life.
I've never heard it put like that. Using it like as a blog post that you come and you read every once in a while, and it makes complete sense. So let's talk a bit more about another dimension of being a data scientist, and that is maybe I want to talk about two pieces. One is influencing in the workforce and showing how can I show my value if I'm creating stuff and I'm putting it out. How do I really measure that? And then the other one is like on a more of a personal level, and what are the most important soft skills that you can have as a data scientist?
Okay, so which one was the first?
Well, let's start with the soft skills and then I'll go to the next one. I've been hitting you with the double question all day. I'm sorry about that.
Okay, so for soft skills, I think for a data scientist, for any software engineer, I think what is important is communication. Like before solving the problem, we need to make sure we understood the problem. And once we understood the requirements, we also need to understand why we're solving this problem. Like what is who we are going to help, like what is the problem that this user has that we're going to solve. And I think these things pretty important in career of anybody in tech, like be it a software developer or data scientist, data engineer, or machine learning engineer, just to understand why you are solving this problem. And of course, communicating. Like once you solve the problem, then you try to show this problem to maybe do a demo, and then make sure that you indeed understood the problem, that this thing indeed solves it. And then talking to stakeholders, being in meetings, trying to convey your message. I think these are the most important skills for people who are coders, right? So who are not yet managers, who are not managers, who maybe don't even want to consider the managerial track. I think this is still important to try to talk to people. One form of communication is writing good documentation. This is also like somebody comes, wants to learn more about the project, then having a good documentation is also a nice thing. And I also think this is like a soft skill in a way, in a sense that it's not the skill you really need to have to do your job well. Like it's not like a hard skill, but this is something that helps you do your job well, like good writing, like trying to convey your message in words. Then maybe also presentation skills, like when you have something, you want to show it, you want people to understand what you build, like explain things, complex things with simple words, try to convey your message. I think these are important things that we should try to have.
And that you pretty much answered the first question there too. Okay. It was more, like I have the idea of I was at a conference and I saw a really cool framework being used, or I saw this really cool tool being used, and now I need to go back to my job and sell it to the rest of the team. Mm-hmm. I need to sell it to the higher ups that we need that. So that was kind of the question. And mm-hmm. I mean, it seems like it's the same answer, but you got to get your communication mm-hmm. skills. You got to be able mm-hmm. to present. You got to show the value in it. So it makes sense.
Mm-hmm.
Now,
can add
sorry,
to that. Yes. So, like, if you want to sell things to people, like, like, here's the cool thing I just learned about. Let's try it. I think the best thing you can do here is try to team up with your product manager, because their job is to convince people. So if you just need to convince one person, this product manager, and then they will help you to actually do the convincing for like the rest of the organization. So I think if anything you can do here is like the best thing you can do is make your product manager your best friend, and then try to convince them first, and they will help you to also like they can help you to work to improve your presentation skills, to improve your communication skills, like your writing. So it's always a good idea, regardless whether you want to sell something to somebody or not, to just team up with your product manager, try to learn from them as much as possible.
Beautiful answer. And I see a question in the chat from Camille. Great question here. If you're trying to get a job as a data scientist or a full stack data scientist, do you need to have knowledge regarding architecture and the scalability, or on the cloud, end-to-end machine learning solutions? If so, to what extent? You mentioned before that it's more like being the jack of all trades, master of none, right? If you need to dive deep into one, you can, but for the most part, you want to know you want to have basic knowledge of the whole that whole pipeline. I look at it like a horizontal, and then if you want to dive deep into one, you can go more vertical. But I'd love to hear your thoughts on it.
Yeah, you basically answered. So what I can say is that for a job, you don't have to know all that, but I think you should be willing to learn that if you need. So the core requirements for a data scientist, I don't think they include like being able to deploy your model at scale of, I don't know, 1 billion events per day. I don't think it's included in a job description of a data scientist, maybe with very few exceptions, but typically it's not. But it doesn't mean you shouldn't be interested in that. And if you're interested, usually like in all the companies where I worked, the management is very happy when you try to step out of your direct job responsibilities and try to, I don't know, wear a hat of a DevOps engineer or backend engineer and try to scale your solution. You don't just stop at, your Jupyter notebook and this pickle file, and then perhaps, I don't know, this Docker container, but you just go a few steps after that and try to make sure that your model serves the real customers. It's not a must, but I think it will help with your career to progress it to levels even after senior.
So I've got 2 more questions left. We've got about 9 minutes. If anyone else wants to throw any questions, feel free to jump in the chat. I want to start with one, which is on LinkedIn, man, people come at you hard. And how do you keep a level head? How are you able to, because I was reading through some of these LinkedIn comments, and when you say things about this that we're talking about right now and learning this kind of stuff and being interested in this, some people really don't like that. But whenever I saw you responding to these comments that are a little aggressive, and some of them I almost jumped in like, whoa, chill, relax. He's just trying to help us out. But you always come back with a very straight, very, calm answer, going right to the problem and the point that you're trying to iterate, and you don't get caught up in any drama. So can you give us a bit of a tip on that one?
Yes, first tip, don't get caught in a drama. So try to avoid
I think it might be the Russian in you that makes it much easier for that to happen, right?
Yeah. Well, I try to not get things personally, because I respect, like, everybody can have their own opinion, right? Their opinion don't have to be the same as my opinion, right? And I respect that, right? So, and if somebody says that data scientists should not be allowed to touch Kubernetes, okay, there are maybe there was a story like in the past of this person when data scientists did touch Kubernetes and basically it broke production, like all the data was erased and I don't know, like something bad maybe happened. Yeah, so I just tried not to take this personally and maybe reformulate the message I saw in my head to be maybe less aggressive, just to get to the point of this, rephrase it in my head, and then answer to that question instead of the original question I saw. Yeah, so this framework I think helps to somehow to to stay out of drama, but still respond to this and not just leave it hanging.
Yeah, I think that's great advice. And it comes down to being this full stack data scientist. I look at it as a full stack data scientist in all facets of data science, but also in life too, when you're away from the keyboard. So it's great to have those skills and you practice what you preach. So last question from me. If anyone else has any other questions, throw it in the chat. It's coming from LinkedIn. Funny enough, ironically enough, there is the question here. At work, I do simple models and build reports all the time. There's no opportunity for me to practice infrastructure related things at work. What can I do?
Well, change your work. But I mean, of course, like maybe like it's like a little bit chicken and egg problem, right? You cannot change your work because you don't do infrastructure things, and if you want to do more infrastructure things, they require you to do more infrastructure things. So how do you get this experience, right? And one of the answers for this is do pet projects, right? Of course, like it's not realistic that your pet project will serve I don't know billion people per day, right? Or I don't know, even a million people per day. It's not realistic to expect this from a pet project, but still getting exposed to like the whole process, like from the beginning when you just think about something like about an idea and then trying to shape this idea into something tangible like a prototype, and then not just stop on that but also deploy it, go to AWS or your favorite cloud or whatever, deploy it there and see what happens after that. Even if nothing happens, you already learned the skills of deploying this thing, and it's already like you touched a few infrastructure related things. And I think it's already valuable, and you can just put this to GitHub, write an article about this, and already your value will increase. And of course, then it's easier for you to change your job and do more things that you want to do, like these infra-related things. And maybe you don't even need to change your job. You can show at work, like, hey, these are things I'm doing in my free time, and I see that there is an opportunity to apply these skills that I learned in this project. Can I spend some time on this as well? Maybe they will agree. If not, then you know what to do.
Yeah.
Go to LinkedIn.
So I see a few more questions coming in here. We got maybe a lightning round coming up. What's the minimum skills that a data scientist should possess?
I think I touched on this a bit. So in my opinion, this is first is SQL. You need to be able to get the data in the form you need. Like that's probably applying in different data sources, so you need to somehow access this. So SQL is probably a tool you need for that. Then once you extracted this data, SQL is not flexible enough to do some things. You'll need to do extra pre-processing, like with Python, with pandas. And then before you can put this into a machine learning machine learning framework, you need to represent this data as a matrix. So you need to know some Python, some NumPy, some pandas. And then once you have this matrix, you put it into a machine learning framework. This is typically scikit-learn. Sometimes it can be maybe XGBoost or TensorFlow or maybe MXNet. And then you need to train a model. So this comes down to trying different models. So basically learning this framework and seeing what models are there and how to use them. You also need to know about cross-validation, like how to set your experiment to make sure the models you create are generalizable, they do not overfit. Once you have the best model you could train, you manage to train, then you go to the next step and try to put it into a simple Flask API in Docker. And I think with that, with just these a few things, I think you cover like 80% of the job requirements of a data scientist. So I think I call this core skills, and with this, it's enough to get hired as a data scientist.
Great answer. So John's got the last answer for us. We'll end it with this one. What's the most influential resource you'd recommend to engineers for learning data scientists? I'm going to put a little appendix on this one. Besides your own book. I mean, John, just so you know, so Alexey isn't self-promoting this whole time. He's got an amazing book out there. Go check it out. We can link to it in the chat. I think that is a possibility right now, Alexey, if you want to throw it in the chat. Mm-hmm. The second most influential book that you can, or resource that you can recommend for engineers learning data science. And John, so you know, if you didn't hear it earlier, Alexey is also raffling off some of these. So get involved in that. We'll put it in the follow-up email if mm-hmm. you're on the mailing list.
Mm-hmm. So one thing I can recommend, it's not strictly related to data science, but it had it was like, for me, it was pretty influential book, is Designing Data Intensive Applications. So this is more like a data engineering book, but it really organizes all these things about like scalable data processing, like all this replication, sharding, like MapReduce, all these things that you need to be a good software engineer. So I think if there's any book that had a big influence on me, this is this book. But this is like more generic data science, or not data science, like software engineering. When it comes to machine learning, so I don't know a book, but for me, it was a course from Andrew Ng in Coursera. So this is why I decided to switch my career and start doing machine learning data science.
What was that course again?
Machine learning on Coursera. From Stanford University, from Andrew Ng. So this is the classical ML course. So if you ask people like what was your first course about machine learning, and 9 out of 10 will probably tell you about this course. So it came pretty early. It was one of the first ones. It's pretty old. I think it's now like 8 years old, but I think it covers the basics really well. And even though it uses Octave, like it's MATLAB dialect instead of Python, still pretty valuable. And I think that this had a lot of influence on me personally, because this is why I decided to change my career. So I do recommend this course, even though it might be a bit out of date, because the basics, frankly, didn't change in 8 years. They are still the same.
Perfect. That is all the time we've got for today. Join us in our Slack community if you want to keep talking to Alexey, or reach out to him on LinkedIn. Follow him if you are not following him. He is your top voice. He should be a top voice if he's not a top LinkedIn voice. Not yet. Make him one. Go there, like all his posts, subscribe to everything, get notifications, whatever that you can do on LinkedIn. And we will see you tomorrow. Just a quick little update. Tomorrow we have a workshop with Dan Gerlang about Dask and Python scaling the data frame. That is going to be very cool. It's the same link. So if you registered for this, you just click on that link again, make it easy for you. It's at the same time. It's going to be for an hour and a half tomorrow, and come prepared to do work, because Dan will get you guys working, get all of us working. That is all I got for today. Thank you so much, Alexey. This has been amazing. The link to the book is here, but we are going to put it in Slack in case you don't see it. I'll put it again here in case you all want to go check it out. Mm-hmm. And I'll also link it in the email. There's nothing much else that I want to say. I think that's it. Alexey, you got any final words?
Yeah, follow me on Twitter as well.
But yeah, of course, I forgot. What is your Twitter handle? Sorry about that.
I am just typing it.
There we go.
Yeah.
Follow him
Well,
on
thank
Twitter.
you for having me. It was a pleasure for me. So
It was great,
I
man.
really enjoyed being here.
I appreciate it. Everyone, I think, really appreciates it. Very inspiring story and great insights from Rustam. And you've been awesome. This has been a lot of fun. We will see you all tomorrow or next week. We're doing these every week, Wednesdays at 6 o'clock CET. Come. You got the link now. Just hop in and say hi, ask questions. Otherwise, if you miss it, it'll be on our YouTube channel. You can find all that info in the email that I'll send as a follow-up. I'll see you all later. Have a great day.
Goodbye.